In this video, we will be doing a general overview of how to solve for the moment of a force. Before we can do that, we must look at the definitions for moment of a force. A force is a vector that pushes or pulls on an object. A force has both a magnitude and a direction. A moment of the force is a force that produces a twist or a rotation upon a point. It is defined by the equation mi equals F times d perpendicular, where mi is the moment about any reference point, F means the applied force, and d perpendicular stands for the perpendicular distance from I to the line of action of the forces. D perpendicular is also described as the moment arm. Now let's take a look at the few types of support reactions. A roller reaction is where there is one unknown reaction that is perpendicular to the support. It is commonly represented as shown here. A pin or hinge reaction is where there is two unknown reactions, Rx and Ry, as shown here. Lastly, there is the fixed support, where there are three unknown reactions, Rx, Ry, and Mr, as drawn out here. Now let's look at the basic problem-solving steps when looking at a moment of the force problem. The first step is to determine the x and y components for the reaction. An easy way to look at this is to draw a triangle representing the force direction and magnitude. The value for A corresponds with the x component. The B value corresponds with the y component. The second step will be to determine each component in terms of F times d perpendicular. This will be represented as f of x times d perpendicular to y. And for the y component, it will be represented as f of y times d perpendicular x. This step will determine each component and what will be inputted into the equation. The next step will be to place the components in the equation and to add them together to solve for the equation. This could be seen as m of I equals f of x times d perpendicular to y plus f of y times d perpendicular to x. It is important to note that in the case that multiple forces are being applied to a singular point, you will need to determine each x and y component and add them together to solve for the equation. If two forces are being applied to a point, it could be shown as m of I equals f of x1 times d perpendicular to y1 plus f of y1 times d perpendicular to x2 plus f of x2 times d perpendicular to y2 plus f of y2 times d perpendicular to x2. This will be repeated according to how many forces are being applied to a singular point. It is also important to note that if d is not defined already, the distance can be determined by using the slope formula using cosine and sine. Once you have solved for this equation, you will have successfully found the moment of a force. Thank you so much for watching this general overview of how to solve for the moment of a force.